Hello everyone, I'm Pawan Arora and with another video, and this time I'm sharing control charts with you. So control charts are actually of two types. One is called variable and then attribute control charts. Today I'm talking about variable control charts or the control charts which used variable data. Uh, as the topic is lengthy, so I'm also splitting this video maybe in two or three parts. Okay, so today we will talk about variable control charts. So the first thing when we talk about control chart is the control limits. Now what is the meaning of control limits? So normally in control chart we have a limit from plus or plus minus 3 standard deviation. Why we have plus minus 3 standard deviation? If you look at this figure, this is the normal bell curve, everybody is familiar about it, right? And we have the process average in the center, and then we have the standard deviations. You can see plus and minus 3 standard deviations. So overall distance from here to here is 6 standard deviation. So this 6 standard deviation is mostly it's cover 99.73% of the area. It means 99.73% of the data points are coming into this area. Okay, so I'm not talking about specification limit which customer gives you. So please have a look. These are the customer specification limit is LSL, lower customer specification limit, and this is called UCS, which is called upper customer specification limit. So I'm not talking about this. So please note, control limits are not the specification limit. So I'm talking about this one, minus 3 standard deviation and plus 3 standard deviations. Or indirect way we can have a limits like this as well. So this average is nothing but the center line. You can see the center line. So what I'm doing is I'm just converting this vertical chart into the horizontal charts. So this is your plus 3 standard deviation, minus 3 standard deviation is here. This is called UCL and this is called LCL, right? This is called UCL and the bottom one is called LCL. And not only that, if somebody wants, okay, what is my plus and minus 1 standard deviation? So this is the area of plus and minus 1 standard deviation. This is the area for minus 2 standard deviation and plus 2 standard deviation. So any data point in a normal way, any data point which is lying between plus minus 3 standard deviation is called the random variation. Means the data point like this, these are the data points which are lying under plus and minus 3 standard deviation. This is called random variations. Random variations means these are having, or the inherent variations, these are variations are there in the process. No need to worry too much about this. Okay, but sometimes the variation something like this, you can see this is called assignable cause variation. Assignable cause variation means the variations which is coming because of some assignable causes. Let's understand, if I'm having a medicine, okay, and I know, or I want to know the medicine, you can say the reaction time of the medicine, or the I would say the time when the reaction, sorry, the medicine will start giving relief to the person, relief to the body, is let's say 24 hours. So after 24 hours the medicine will start giving relief to a body. But so sometimes it will give in 23 hours, 24 hours, 26 hours, 27 hours, like this. But suddenly the medicine, if it is giving let's say 48 hours or 56 hours or 72 hours, these are the out of specifications, or out of control limits, right? Because the timeline that we set is 24 hours. Maybe I will say the standard deviation may be plus or minus 1 hour. So in that case this will become your plus 3 standard deviation and this will become your minus 3 standard deviation, and the average will be 24 hours. And if I'm saying 56 hours, obviously it will be out of your upper control limit. So this is your upper control limit will be 24 plus 3, 27 in that case, and 24 minus 3 will be 21 hours. So if anything between 21 to 24 hours, that will be called as random variation. And if it is going out of that, then it will be assignable cause variation. So that's the benefit of control limit. You can see whether your data is in the control limits or out of control limits. Okay, but again, I'm not saying whether your process is capable or not. So if you want to understand whether process is capable, then you have to watch my another video on process capability. So here I'm talking about the stability, whether your data is stable or not. So if the data is not having any assignable cause variation, then I will say yes, data is stable. But now here we are talking about only two things. One is plus and minus 3 standard deviation, or lower control limit, upper control limit on the basis of plus and minus 3 standard deviation. But not only that, there are total 8 rules, that's called Western electric rules. Okay, so these are the 8 rule you can find in the minute. Time, no need to remember it, but the majorly we use this. The first rule, you can see 1.1 of the data point is greater than k standard deviation. What is the meaning of k here? K is written here. So if one data point is greater than 3 standard deviation, which is nothing but our previous case, or this case you can say the number 1, then the process or the entire data will be called as not in control, or the process is not in control, or that particular data point has some assignable causes. Now coming to this point, you can see in Minitab, when you actually plot these kind of control charts and you will select perform all the 8 Western electric rules or electric test, then it will have all these. So you can see it will show you red colors which are not following, or any data point which are not following these rules, or coming like a deviation in that rule. So for example, you can see here this is number 4. Number 4 means 1 2 3 4, means this particular data point is not comply with number 4, or the fourth rule of Western electric, which says k points in a row alternating up and down. So k means 14. The meaning is if 14 data point in a row means continuously, okay, or consecutively are alternating up and down. So if in this case also this is down up, this is down up, now this is your already out of control, so you have to count from here, up down up down up down like this, and this will be your 14th data point, which is up and down continuously. So then it will not follow the fourth rule, which says 14 points in a row alternating up and down. Okay, so that is called Western electric rule. As I said, no need to remember this is already there in the Minitab, which I'll show you in another few seconds. Okay, let's move on and understand what kind of variable control charts we have and which control chart when to use. This is very important slide, please be careful here and listen to me very carefully. Now the first thing is, if your subgroup size is less than equals to 8, then if less than equals to 8, it is no. So my subgroup size is not less than equal to 8. I have to use Xbar S chart. Okay. If your subgroup size is less than equals to 8, yes, it's less than 8, then you have to say, is it 1? If the subgroup size is 1, then you have to use IMR chart. I've already created a video on IMR chart. You can go and watch. Okay. If your subgroup size is not 1, okay, but it is less than 8, but it is not equal to 1, please note, then you have to use X bar R chart. So in a simplified way, if your subgroup size is greater than 8, you have to use X bar S chart. If your subgroup size is greater than 1 but less than 8, then you have to use X bar R chart. If your subgroup size is 1, you have to use IMR chart. Okay, so today I will talk about X bar S chart. Indirect way, when your subgroup size is greater than equals to 8. Okay, sorry, greater than 8, not equals to 8. If it is greater than 8, then you have to use X bar S chart. Now greater than 8 means when your subgroup size is 9 or more than 9 in simple way. Okay, let's move on. Now, X bar S chart, as I mentioned, when your subgroup size is 9 or more, then you have to use. Now, widely when to use the X bar chart? Widely, we want to check the stability of the process. Then you have to use X bar S chart. Now, please understand what's the meaning of X bar and S. So the first term which called X bar, X bar is nothing but your average, and S is nothing but your standard deviation. So this chart is also called average standard deviation chart or mean standard deviation chart as well. So in many industry, whenever we are checking or whenever we are examine the stability of the process, we will use this chart. But you have to remember always that the subgroup size should be greater than 9. Now what's the meaning of greater than 9? I'll let you know. Suppose there is an example. Let's take a very realistic example here. So you are conducting a study on blood sugar level of 9 patients. So here this is 9. 9 means your subgroup size. 9 patient is your subgroup size. So when your subgroup size is 9, so you have to use Xbar S chart. And now you are conducting a study of blood sugar level. So it means you have taken a blood sugar level of number 1, number 2, number 3, number 4, number 5, number 6, and so on. Okay, who are on strict diets and exercise routines. Now you take a blood sugar reading every day. You can say you can see the readings for the first day, then you have the reading for the second day, then you have 9 reading for the third day. So every day for 20 days you are taking 9999 readings. So every day I am taking 9 reading from 9 patients, right? One patient, one reading, so total 9 readings of blood sugar level I am taking. So what I am doing is total 9 subgroup size I am taking every day. So what is the meaning of subgroup here? If I am taking 9 samples, 8 samples, 5 samples, so accordingly your subgroup size will be 9, 8 or 5. So in this case we have 9 samples. Okay. Now first I'll try to explain you in the simple Excel file, and then I'll try to explain you in the Minitab. Okay. Now let's go and show you what is there in the Minitab, sorry, in the Excel. Okay. Now, so these are the reading which I was showing you. Okay, please ignore all these whatever I written here. I will take it within few minutes. But for now, just remember these are the total 180 readings or 180 data points, or every day 9 samples. So 20 days will be 180 data points. I just copy this and I will paste it into the mini tab, right? Just paste it into the mini tab. Now in the Minitab, I want to see whether the data is stable or not. I want to check. Okay, because this is what the question is. We want to check the stability of 9 samples every day. I am taking 9 sample till 20th day, and I want to check whether the blood sugar level is stable or not, because these patients are on strict diet. So how to check this? What you can do is just go to stat, go to control charts. There are control charts for variable and individual. So here I'm not using individual because my data point is having subgroup, and in subgroup I'm having 9 subgroup, or the subgroup size is 9. So I will use X bar S chart. So when you use X bar S chart here, all the observation of a chart in one column, yes, these are the observations in one column, which is blood sugar level, and the subgroup size is what, 9, right? So when you click 9 and when you click this, you will be having everything. Now multiple graphs, if you want, you can click this. The scale, if you want to have some index or stamp, if you want to put, you can click this. Mostly I leave that. In the label, if you want to give any titles, subtitles or something, you can use this. Data option is very interesting thing. Now I want to leave some gaps, or I want to exclude some point, I can use it. Okay. Last but not the least, X bar options. If I already know the mean or the average of the data, I can put, or if I want to put a proper mean, saying that I want a mean of 50, assume, so I can write 50. I want to have a standard deviation of this, I will put here. But mostly whenever I'm checking the control charts, I never put this. Now this is very interesting, limits. If you put here 1, 2 and 3, this will show you +1 standard deviation, or the one limit plus one standard deviation limit, then second limit and the third limit. The third limit is nothing but your upper and lower control limit. If you want, you can do it. For now I'm not applying it. Okay, and finally okay. So when you click OK, it will give you a graph. Actually it will give you two graphs. Let me just explain in that way. So on the bottom you have a standard deviation graph. Okay, so you can see total, you have total 19 data points, sorry, 20 data points. So you can see from here to here you have 20 data points, and for this also you have 20 data points for X bar chart. So on the bottom this is called S chart, and on the top this is called X bar chart, or standard deviation chart and the average chart. But please always note that whenever you are using or whenever you are checking these graphs, please always note that you have to check the standard deviation graph first, and then you have to check the average chart. Okay, the reason is the X bar chart, the X bar control limits will derive from your S bar chart. So if your S bar chart is out of control, then automatically your X bar chart will be out of control, or there is no meaning of checking this, because your X bar chart will check both the average and the spread. Okay, now by looking at both the graphs here, it is looking in control because I don't see any data point or any assignable causes, right? So by looking at this, I will say okay, the blood sugar level for all these 20 patients are in control. Sorry, all these 9 patients are in control, right? So these kind of conclusion you can do. Now the thing is, you have to also understand from where or how these graphs are generated. That's the most interesting thing that we want to know, right? So let me explain you how these graphs are generated. Let me go back to the Excel file and let me show you. This is very simple actually. So these are your 20 samples, right? 1 2 3 4. So this is your one sample. One sample means one day I have taken these 9 sample. So for these 9 sample, this is the standard deviation. For these 9 sample, this is the standard deviation. Okay, how can you check? You just put STD, standard deviation for samples, right? And from here to here, you just, sorry, you'll get this, right? 24.35. Let me just keep it in a simple way. So same way you can get the standard deviation for all. So if you want to know how to calculate standard deviation, you can watch my previous videos. Now average. So this is the average for every sample. Every sample means this is the first day. You have 9 samples here. So if I take the average of these 9 sample, you can see on the bottom average is 92.11. So this is written here. So the first and foremost thing, I have to calculate the standard deviation, then I have to calculate the average. Okay, now you can see this is our chart, right? This is our X bar, S bar, sorry. So this S bar is nothing but this S bar is nothing but the average of all the standard deviation. These are the standard deviation. If I take the average of this, is coming as 29.24, right? So this is the average 29.24, 29.24 and all. So this is the average you can see here for this chart. Now there are some control limits for upper control limit and lower control limit, but before that you can see there is called X double bar. So X double bar is nothing but the average of these means. So if I take all the means, average of average in direct way, so this is coming 101.03. So this is 101.03 which I mentioned here. So this is the formula for X double bar. Now for the upper control limit and lower control limit, there is a formula which use some constant. So you can see there are some constant as 1.76, there are some constant at 0.239 and so on, right? So for this I want to show you the clear picture. I hope it's clear for you how this average is coming. And now I will talk about how these control limit, upper control limit and lower control limit for X bar, as well as lower and upper control limit for S bar, how it comes. Okay, let's go back to the main stream. This is the formula. This is the formula for X bar chart control limits, which is nothing but X double bar, which you already know now, plus A3. Now what's the meaning of A3? A3 is nothing but it's a Shortcut constant, because the control limits are derived by Shortcuts. Okay, so these are the control limit, and these Shortcuts control limit depend upon the n. N is nothing but your subgroup size. Okay, so now for X bar chart, in case of X bar S control charts, when you draw X bar chart, you use A3. A3 in the sense this is your A3. In our case, the total number of data points or the subgroup size is 9. So for this case is 1.032. So what I will do, X bar plus minus 1.032 multiplied by S bar. S bar is nothing but which is the average of your standard deviation. Similarly for UCL and LCL, for S bar, okay, now this is the formula for UCL and LCL, please note. So this is UCL X bar when you have plus and LCL X bar when you have minus. Okay, same way for X bar chart, when you have UCL as B4 S bar, B4 is nothing but it's here, so B4 for number 9 is 1.76, and similarly for B3, so B3 is here, you have 0.239 multiplied by S bar, right? So when you use these kind of formulas, you will have your upper and lower control limits. Okay. Now I want to show you this in the Excel file. You can see in the Excel file the upper control limit for X bar is using 1.761, right? Let's go back and see. This is your 1.761 because it is using B4 for upper control limit. So this is 1.761. If you see the formula, 1.761 multiplied by S bar. So for each and every point you have your upper control limit as 51.49 something. Similarly, LCL is using 0.239, correct? Sorry, this is using 0.239. So here you can see B3, which is 0.239 for subgroup number 9, or when we have subgroup size as 9. So this is using 0.239 multiplied by S bar. So here H2, which is your S bar, multiplied by 0.239, which is coming as 6.99. So this is your 6.99, which is coming from the Minitab. Okay, same way you can calculate the UCL for X bar and LCL for X bar, where you have to use the formula of X double bar plus A3 multiplied by S bar. Now the important thing is this, that you have to remember. As I mentioned, whenever you are using or whenever you are checking these X bar S chart, the first thing is you have to check the S bar chart or S chart first. The reason is because when you are using S chart, your X bar chart, actually it's coming from your S bar chart. If you see the formula here, this is coming from your X bar plus S bar. So that's why this is the X bar chart is not only coming from the average, it also coming from the spread. So that's why you have to check always the S bar chart first. Okay, the second thing is, if your S chart is out of control, then the control limit of X bar chart may be inaccurate because your S bar chart is already out of control. Okay, so that's why whenever you are checking as X bar S chart, check S bar chart. If you are thinking S bar chart is out of control, so please understand, maybe your X bar chart will guide you or will falsely indicate some of the things, because your all the limits are coming from for X bar chart is coming from S bar chart. Okay, so please note that you always need to check S chart first, and then you have to check the X bar chart whenever you are reviewing X bar S chart. So it means whenever you are checking your X bar S chart, you have to carefully understand that your data point or your subgroup size should be 9 or more than that, and then you have to review your S chart first. So by looking at this, your patient's or the sugar level of the patient is looking in control and the process is stable. So I hope you understand how to calculate X bar S chart. If you have any question, you can write the comment on the YouTube. Okay, thank you very much. Have a nice day.